Uh, yeah, so yeah, let's try this. So next slide, please. Yeah. So today's agenda, so we'll cover what is NF test, and we'll look at the current testing framework in NF Core that is using PyTest. We'll look at some differences, and then we'll go on in the hands-on part to write some module tests and pipeline tests for the NF Core AmpliSeq pipeline. And I'll leave with some additional resources further, because this is a quite new tool that's coming to the community, and we are just wrapping up its adoption. So I'm actually excited to present to this community and see hear the feedback and see what the Welcome Institute thinks about this. So let's move on. Next slide, please. What is an F-test? Testing framework for Nextflow pipelines specifically, and it's based off on Groovy. It was created in 2021 by Lucas and Sebastian. Let's move on to the next one. So a quick comparison, diving straight in, NF-test versus PyTest. While NF-test and PyTest both are testing frameworks, they differ in their structure, implementation, and features. I mean, PyTest has been around for a while, and it's quite well adapted in the community. But this NF-test has been specifically been created to work with Nextflow pipelines. So let's look into the differences, because there's no replacing one with the other. Sure, might be using NF-test a lot, but PyTest also has its own utility. So I just want to highlight some differences and point out some areas where NF-test might offer some advantages over PyTest workflow. So we'll go into that. So you have to press down here. Right. So just broadly on the differences on structure and implementation. NF-test is built on Groovy, PyTest is built on Python. NF-test is specific to Nextflow, whereas PyTest is a more general purpose testing framework. Now, the unique part of NF-test is it provides specific assertions for testing on Nextflow channels. And whereas PyTest doesn't recognize any such specific data structures like Nextflow channels. So we have to get through just checking for output files or the output produced by either the process or a workflow. So that's one powerful feature that is really attractive when you are setting up unit tests for your pipeline. So next slide, please. Okay, so let's look at the current framework for NF Core modules. I hope everyone here has contributed in some form or the other to the NF Core modules repo. To go down, the process is usually once you have finished integrating your module, you create the test YAML file, and most probably each module will have a main workflow file, and this is an example of BCF tool sort. So you can see in the main file, it's almost like an Nextflow workflow itself, where you're including the process and then calling on upon the workflow and providing inputs and calling upon the process. If you go down, and in cases where you had, when you needed additional tests, you would import the process under multiple aliases so that you can run it multiple times for as many tests as you need. Down, please. And additional parameters are defined in the specific nextflow.config file in that for that particular test directory of the module. And also, once you have, if you go down, the test outputs and appropriate checks are listed in the test YAML file. And this YAML file is what PyTest is usually looking for, where we can specify the checks that we are intending for that particular test. And most usually, this will contain an MD5 sum, the kind of like the file integrity check of a particular file. and also the path to the output file if present. So this is currently the framework. So and we use the NF-core helper tool command, the modules test command, to actually run this and check whether the MD5 sums match. So this functionality is great, and it's like the bedrock of testing of all the NF-core modules. So what we'll be showing in NF test today is we'll be pretty much be having the same functionality with NF test, plus additionally we can do much more to get into depths of when just checking for the MD5 sum is not what you want. There are certain specific pipelines and medical and clinical regulatory control pipelines where you have to check for the specific output in your pipeline. So through NF test, it becomes much more easy. I hope to show that to you in just a couple of minutes now. So let's move on to the next one. So that was for the module, right? So we use pytest framework, actually the NF-core tools and the pytest framework to create tests for the particular module. And the current testing framework for pipelines, like at the pipeline level, like looking at the NF-core AmpliSeq pipeline. Actually, I think we'll be going down there. Yeah. So all pipelines, all NF-core pipelines are rigorously tested, right? So this is happening through the continuous CI through GitHub Actions. And this will look something like this, where it's basically running the different test profiles that each NF-core pipeline comes with to make sure that the pipeline still runs successfully. So this is currently one area where we are trying to look to improve. Is all the pipeline level testing is just looking for whether the workflow succeeds or not. But we want to be more granular in actually checking for the exact outputs produced by each of the pipeline. So at this point, pipeline level testing is through the GitHub Actions on CI, and you're just basically testing for different test profiles. So if you go down, right. So what are the current testing framework limitations? Like, given PyTest is used only for modules and pipeline testing is through GitHub CI. These are just few that I've listed. So the local execution process can be challenging for newcomers due to the need to understand Python, because PyTest, when you have to run the tests locally, manually, you have to set up your particular local Python environment so that you can be able to run this particular PyTest and interpret those unconventional outputs and handle different containerization technologies, because we have some, you have to test on all the different platforms so that we make sure the GitHub CI passes in the end. So next, please. And there's a need to manually create and maintain MD5 sums. And even though this process can be scripted, it requires considerable effort, which can lead to potential neglect and decay over time. It's an easy process if the file generates a consistent MD5 sum, but in many cases, we see when files contain timestamps or paths included that change, they lead to different variable MD5 sums. And also just maintaining consistent as soon as there are different module version updates, the MD5 sums will also change. So currently there is no automated way of updating the MD5 sums. Today in NF test, there's a feature called snapshots, which I'm excited to share with you, which will make the automation of updating and keeping track of MD5 sums in a much more easier way. And the creation of custom test logic is complex and requires advanced expertise, which could be a significant barrier for beginners. Right. So again, these are just some limitations, not necessarily applies to all. So let's move to the next slide, please. Thank you. Yeah, so introducing, given all the current scenario, introducing NF-test. NF-test, there are many features of it. Test cases can be organized as a suite of tests within a single test file. That means you don't have to include it under multiple aliases. You're just defining different tests, and you don't have to include the same process under different names and have that messy as we have it currently. And each test has a name, a when closure, and a then closure. So I'll show you an example in the next slide. But these closures are what are used to describe what we expect the expected behavior of the process to be. So if you go down next, and NF-test also comes with a set of helper CLI commands. One of them is provides the generate command, which creates a skeleton test code for a Nextflow process or a workflow or a function. And this command automatically fills the name, script, and process of the test case and creates a module for the test method. Currently, NF-code tools does that for us because pytest doesn't have a generate command on its own. So it's currently the NF-code tools creating all of that, the test YAML, and making it easy for us. But NF-test comes with this generate command that can be used to generate skeleton test files based on all the current modules or pipeline workflow files in a repo. So let's look at an example. So if you scroll down, so this is an example of an NF-test file. So this is for BCF tool sort. So all NF-test files are recognized by the .nf.test extension. This particular extension is used by NF-test to recognize all the different tests in a particular repo. So .nf.test is the extension for NF-test files. And if you see in this process, it's pretty much an Nextflow process, but the name is the name of this particular test. Script represents which is the file that is being run. And the process represents the process name from that particular file that is being run. And config is you're specifying a particular config here, just like in pytest case where we have a specific nextflow.config file for that particular test. We are using the same. So just like in Nextflow, where we can override configuration parameters, NF-test also offers either global setting of config parameters or local overriding, and on a per test basis overriding, because when you have multiple tests in a particular file, you can set different config files for each particular test as well. So it allows overriding of configs as well. And tag is a tag to help sort out. You can use the tags to run, say, NF-test run on this particular tag, all pertaining to one particular tag. So that's the utility of the tag. And every test starts with a test name. So here you see the test, the name, I have put it as SARS-CoV-2 Illumina VCF, because that is the data that I'm using in this particular test. So if you scroll down in this code block a little bit for me. Yeah. It primarily consists of, the test primarily consists of the when and the then block. So the when block is used to define the parameters and the inputs for the particular process. And if you scroll down, the then block is where you can write your assertions that you expect from this particular process output. So in the when block, you can, again, if we can scroll back a little bit again to the when block. Yeah. So in the when block, you're basically defining different parameters. Here, we're basically setting the outer. And in the process, the inputs are provided referred by their index numbers. So in this particular BCF sort process, It's taking a single input of a tuple of a meta and the file. So the input has to be provided as input square bracket 0. So you're basically indexing the position and saying this is the input that needs to be provided. Yeah, so that's about providing inputs to the process. And in the then section, we use different assertions. Assert process.success ensures a successful run of the process without any exit codes. And the second line that you see there, where it says assert snapshot, path params.outer.list.match is is the snapshot feature that I'll just introduce to you in the next slide. But this is pretty much the overall layout of an NF test file. So you have the name, the script, the process that's being run, and then you have the test case. And in the test case, you have the when block and the then block. The when block, you provide parameters and inputs, and the then block, you write your assertions. Great, let's move on to the next one. Right, so writing assertions. I would refer everyone to read the official docs, NFTest docs for the different types of assertions, because there's only a little, a part of them that I could cover here today, because I wanted to restrict myself to working examples from AmpliSeq. But there's a lot more flexibility of writing assertions and for different scenarios as well. So I'll just briefly mention those. So if you go down, writing test cases involves making assumptions using assertions. That is, you are not assuming anything, like, so you write an assertion that this pipeline should produce 20 BCF mutants. So you write an assertion for that because you want to check for that. And Groovy's power assert offers detailed output when the Boolean expression evaluates to false. So we make use of that in debugging what went wrong. And NFTest simplifies this process with several extensions and commands tailored for Nextflow channels. So that's where the power of Groovy comes in, because you can now do a lot more range of assertions on output channels that previously you might have been limited to. So just some of the examples, if I go down. So there's this asserting on channels width. So it allows you to assert the contents of a channel, of an item in a channel by its index position. You can assert using contains, so that you can assert any item is present in the channel anywhere in the channel, and assert contains in any order. Allows you to make assertions about the contents of a channel without considering order, because you have to keep in mind Nextflow channels are asynchronous. So there are some situations where order matters. So these are all the different workarounds, different features for writing power assertions on items in your output channels. Great. Again, I would refer the official documentation. They have nice examples on their official docs for each of these different scenarios here. And I'll leave you to that. So let's move on to the next one. I think it's snapshots. Okay, files. Yeah, so a little more, how are we doing in time? Okay, a few more examples on what features are available for files testing. You can do MD5 sum checks. As you can see here, you can assert the path of a particular output channel and .md5 and make sure that it matches the MD5. You can match JSON maps and also assert particular key value pairs to make sure that it matches, the assertion matches to a particular key or value that you're interested in. So if you go down, gzip files. It supports support for zipped files. So using the .lines gzip and .contains, you can check whether a zip file contains any string or any content basically that you're looking for in a particular item in a channel. And also you can filter for lines. So this is exactly where I found it very useful to snapshot to filter out lines that might contain timestamps or paths that might prevent you from making getting a consistent MD5 sum. So this ability of filtering lines is also very useful in particular handy situations. I think there's one more, and grep lines as well. So you can basically grep lines in gzip files as well. So again, these are all examples well explained on the official docs with enough explanation there as well. I just wanted to list out these different types of assertions on files that you can do. Okay, let's move on to the next one. And now we are here to snapshot. So this is the, I find the most powerful feature of NFTest. So snapshots are incredibly handy when you want to ensure output channels or output files don't change unexpectedly. A typical snapshot test case creates a snapshot of the output or other objects and then compares it to a reference snapshot file stored with the test file, the .nf .test.snap. It's similar to pytest, like because you run the test first and then you rerun to make sure the MD5 sums match. It's a similar concept, but here with the snapshot, we have much more power with or much more flexibility in asserting on different kinds of outputs and channels. And if you go down, the test will fail if two snapshots don't match, and this indicates either an unexpected change or the reference snapshot needs updating to reflect the new output of a process, workflow, pipeline, or function. So this is a great way of making sure nothing breaks unexpectedly. And this is something that you want as part of your CI to make sure no one small change has caused some unintended consequences in your pipeline. So if you scroll down, the snapshot keyword creates the snapshot of an object. So whatever is within the snapshot keyword method object is captured, and the .match method is used to check if it contains the expected data from the snap file. So I have an example of it in the next slide. Next slide, please. Yeah. So here is an example of asserting a snapshot of a particular file, fastqc.html in the fastqc folder and .match. So the first time this particular snapshot assertion is run, it creates the snapshot file that looks like this. It contains the test name, it contains the .html, and it contains the MD5 of that particular file, and it also contains the timestamp. And if you go to the next slide, let's say the file has changed for some reason, and this is an example of how a snapshot failure would look like. So once the snapshot file has been created, and again, let's say someone has changed something, and then you rerun the test again, it compares the previous snapshot to the current snapshot, and it'll tell you exactly, okay, I found a different snapshot, something is wrong, and something is off. So yeah, this is a great feature because in the next slide, you will see, if you go down, yeah, there's a very easy way of updating the snapshots as well. So when we make code changes and also maybe updates, version updates, software version updates, you have to update the snapshot as well. And this, we feel, we can be part of an automated system where every time there is a version bump or a module update or a template merge that happens to the pipeline, we can trigger, add update snapshots to the CI as well, and make sure the snapshots are updated as part of a continuous integration process as well. Right. So that's all for the introduction. Now we'll dive straight into the exercise. We'll be using, well, I've laid out here to use Gitpod, basically using the Gitpod environment, which comes with an nftest involved, nftest install, and we'll clone the AmpliSeq repo. If you're just using your own, make sure you're in the AmpliSeq repo and you have nftest installed. So I think I actually have that. Could you go to the next slide, please? Yeah, there we go. Yeah, so we'll be generating tests for modules. And so we'll be generating first a test for one module within the pipeline and one end-to-end pipeline test for the single end test profile. So if you're following along with me, you'll need to open the NF-core AmpliSeq in Gitpod. Or if you're working off locally on your own, make sure that you're in the AmpliSeq repo master branch and you have nftest installed as using those commands there. So we'll give a couple of minutes for the Gitpod to open up, and if anybody has questions in the meanwhile, feel free to jump in.
Hey, Sateesh, do you need me to do something differently so people can see the process? Because most people are actually just watching it rather than following along. So if you, should I be clicking on something, or are everything included in the slides?
Everything is in the slides. So Priyanka, so what we can do is, could you split your screen? Could you have the Gitpod on one side and the tutorial on the other?
Try that. Maybe let's try.
It's so easy. Like, oh wait, I think I have screen share now.
Oh, perfect.
Oh no, no. Oh no, it's just the whiteboard still. Oh damn.
Why? I'm going to see if I can. I'm going to try one more time to make you. Okay, you're host now. You've started screen sharing, it says.
Okay, yeah. I mean, yeah, it's not my, I'm trying to, it's giving me a point of screen, not the full screen.
Just stop sharing and try sharing again.
Okay, I'm gonna try this. Okay. Okay, there we go.
We can't see your screen. It's a black for us.
Oh, I thought it was equal. Yeah, sorry, I don't think I can get this.
Okay, so I'll do it.
Oh, thank you.
So do you want me to split my screen?
Yeah. So if you have the Gitpod open on one half and the tutorial on the other.
Let's see if we can do that.
Would you mind sharing the link to your slides again, please?
Sure.
So when I go to the workspace,
Thank you.
Sure.
I can get it.
Okay. Yeah, this will work.
Okay, let's see. Just tell me what you need me to do.
Right. So now back in slides, if you could scroll down. Scroll down actually. Yeah. Okay. So I'm assuming everybody has their Gitpod open. And NFTest is already installed in Gitpod, so you don't have to worry about it. So the first thing we'll do is the first command that you have to do is to initialize NFTest. So the command is nftest init. And you can also, sure, yeah, go ahead. And when you run the nftest init, it initializes, or what it does is it creates the nftest.config file under the nextflow.config that you see there. And also it creates the tests folder to your left if you see there. Right, yeah. Right. And if you, in the slides, if you scroll down, yeah. So after initialization, if you open the nftest.config file in VS Code, it's below nextflow.config here. At the one below nextflow.config. nftest.config. Yes, that's correct. Yeah.
For my small screen.
Yeah, I think you're just opening multiple tabs. Close that. Yep, there you go. Yeah, perfect. Thank you. So in the nftest.config, here you can see this is where we set the test directory, the work directory, and we set the global default config file. And when we initialize in nftest initially, it always sets it. It first creates the test repository if it isn't there, and then sets it to the Nextflow config within the test repository. But right now we wanted to use the existing Nextflow.config of the pipeline. So what I want you to do is in the line number 5, you delete the test slash and just make it Nextflow.config. Correct. Perfect. And save it. Yep. That's the only change because we wanted to use the already existing nextflow.config. So that's the only change for config. So we initialized nftest and then we changed. You can provide different profile options here as well, but we'll specify that in the test files. Okay, so now let's move on to the next slide here. Right. So the first test we'll create is for the modules, and we'll create the test for the FastQC module here. So the command for generating the test is, you can copy paste that, Priyanka. Yep. nftest generate process modules, and basically you're providing the path to the module main file. Sure. Okay. Yeah, go ahead. Sorry. It's not too many commands, so it's not too bad. Yeah. Generate process. So the generate keyword is looking for which type of test to generate. So here the type of test is process. If it's a pipeline, you'll say generate pipeline and provide the path to the main file. We'll generate that in the next section. Right. So you see it has created the test file. So let's go ahead and open the test file here first. Yep. tests, modules, and main.nf. Yeah. So your test skeleton will look like this. So this is what the generate command does. So you see that it gives the test a name. The script section contains the path to with the module main file, the process name, and it gives you the test and when and then blocks. So in the slides, if you scroll down, yeah, this is what it looks like. Scroll down one more. The changes that we're going to do. So this is all description on what exactly. I think we have already went through this before. So just keep scrolling down and we'll go directly to the changes that I want you to make. Go on one more. Yeah. So now to this test file, actually back one more, to the test file. Yeah. So to this particular test file, the changes that we'll be making is first is we'll provide profile Docker under the process FASTQC. So on line 6, if you can provide the profile Docker. Correct. And the next one is we'll be setting the out dir to output dir. So you can copy paste from the left here or just type it out. And also it's commented out, so you'll have to uncomment it. Right. And then we'll be providing the input. For that, you'll have to copy paste actually from the code block here to the left. So this is basically from the existing NF core module tests, where in the main.nf we provide inputs like these. The only difference is we are providing them. Oh, will you be able to paste? Okay, great. Yes, perfect. Okay, yeah. So we are providing the input for this particular here. And in the assertions, you can see if you scroll a little down, by default, it comes with assert process.success and assert process snapshot process.out.match. If you scroll to the left in the script section here, in the that one in the assertions there, could you copy that second part, the whole assert all part, the whole assert all until the that one, correct. And we are going to replace the defaults here, and because I want to show you this assert all, and also show you, because I've already tested this particular snapshot. If we assert the snapshot on the output channel, it also captures some files that don't create a reliable snapshot. And just for the sake of time today, I wanted to make sure that you all have a successful snapshot that's consistent. So yeah, so go ahead and once you have made all these changes, so all you have done is that you have specified profile, you have provided the output there, provided the input, and you have made some assertions. And in this particular case, the assertions are you're checking for process.success, and we are asserting in the snapshot one particular file called test-fastpc.html. So let's go ahead and run this particular file. So if you scroll to the next slide here, it has the run command. Yeah, so the run command is basically nf test and the file, the path to the particular test. Yep. So you can see, just like Nextflow, it gets its own work directory. And notice the .nf test folder that is created. So that's where all, just like the work directory of Nextflow, that's where nf test does all its work. Yeah, if you click on that. So the meta portion, they do some really nice organization of it. The meta portion of it contains all the different parameters that were used to run the particular test. The output section contains the output, and the work is the particular work directory for that particular test run. These will become quite important when you're especially debugging. So it's good to know what the .nf test folder holds. And as you can see, there you see it has passed. And if you go to the test folder now, if you scroll down, it should create a snapshot .snap file. Yep, that one. And yeah, so you'll see there is the snapshot of this particular file. And if you rerun the test again, so if you just press up again and rerun the test, now this time it's going to run the test again and make sure it matches the snapshot, and only if they match will the test pass. Great. So that's I mean, I've tested this out, so that obviously will work. But again, this is quite very basic method of asserting all the different outputs in a particular channel for a module. Does anybody have questions, or anybody have issues running this particular test for the module? Because we have just finished the test for this particular module. Or we can move on to the next one. Oh, I think we have one. I'm so sorry. Yeah, I think I'll still leave some time at the end for questions. So if this has worked for everyone, let's move on to writing a test for the pipeline. So this was writing a test for just the module, and that's how your output should look like. So now let's move on to writing a test for the pipeline end to end. So for this, we will, so you go back one slide and there are some instructions there. Oh, wait, yeah, move on. Could you press up on this? Yeah, one more. Yeah, there we go. So now let's generate a test file for the pipeline main.nf. So for this, like previously how we did generate process, for this we use generate pipeline. So nf test generate pipeline and directly the main.nf. Yeah, main.nf, and it should create a main.nf.test file in the test repo. So if you do that, yeah, it's there. Yeah, that one. So here you can see the name of it is test-workflow main.nf, and it's the script, the test file it's testing is main.nf. And we'll do something similar here. So if you scroll down, when we are, so the difference between module and pipeline is for modules in the when block, you have to provide the process inputs. But on a pipeline level, we can just provide the different test profiles that are already existing. So what we'll do is we'll just provide the tell instructor to use that particular test profile, and you don't have to provide any inputs because it'll just use the test config file from conf. So if you scroll down, the changes we're going to make to this is we're going to add profile test single and Docker, and because we'll be testing the single end, test profile and Docker, and again same output there to out there to output there. And also one thing, you can give a custom name for a different test. So there where it says test without failures, you can give a custom name as well. And in most cases here, we're advising people to give the name of the test data set that they are testing. So that's totally optional. And in the test assertions, I have gone through and filtered out consistent files to go into the snapshot and also different kinds of assertions. So I'll explain that in just a bit, but we can get this test going. So if you copy paste the assertions there. Yep, there we go. So this is a range of assertions ranging from asserting workflow.success to including certain things within the snapshot. I'll talk more about it. Let's go ahead and actually set it off for test. So the next command should be to nftest run this particular test. Tests main.nf.test. Yep, there we go. Right. So as it is running, so now you can look at the different assertions there. There are basically two different kinds of assertions. One is either it goes into the snapshot or we are doing a file exists dot check. So if you see, there are assertions that say insert new file dot exists. Using the dot exists method, we check whether that particular file exists or not. So the idea with pipelines is it is still evolving, but we try to snapshot everything that the pipeline outputs. So that's basically that has been at least my trial, at least for AmpliSeek. So I would run the test profile once and try to snapshot everything. And of course, there will be many files, especially HTML files don't generate consistent snapshots. And also many files that, as I've said, include paths and timestamps, they don't generate. So it's kind of like a filtering mechanism. You kind of like first try to snapshot everything, rerun it, whatever has failed, move those failed ones to .exist checks to make sure that at least you're checking whether they exist or not. And if they can generate a consistent snapshot, they can go into the snapshot of it. So I want to talk a little more about the snapshot. Just like, could you collapse the left bar for me? You can click on the file icon at the top left. Yeah, there we go. Yeah, so one line of snapshot. So if you see, let's look at the second line after workflow.success. So here we're saying assert snapshot pipeline info software versions.yaml. So every NF core pipeline produces the software versions.yaml. And within that match method, we are providing a particular name. So this is kind of like similar to the emit keyword we use in output channels in Nextflow. You're giving a specific name. So it's the same that here we give that particular name to this particular file within the snapshot, because we use different times the snapshot keyword, but it produces just one file. So there'll be multiple things within your snapshot. So it's by adding a name to that, it will help in organizing or adding that particular name so that you can identify that file by that name within a snapshot. So once this test finishes, we'll open that snapshot and see how the different names within the dot match that you're seeing here show up in the snapshot as well. So yeah, so basically you can see here, I went through each different, if you're familiar with that, and all of you are familiar with AmpliSeek, you recognize the output, gone through each different folder within the output and tried to snapshot it. If they can't be snapshotted, may change them into .exist checks. And if they can be snapshotted, add them in, and you can add multiple files. And there's also a .list method so that you don't have to actually manually list all the files, but unfortunately it turns out that you have to most of the times. But if a folder contains files that generate, that don't have any file timestamps or thing, you can use the .list method as well, and you can save yourself some space within this thing. But there's no problem with having a lot of verbose tests like these, because you're making sure that you have specifically checked for everything and you have not left out any one particular file. So now the test has finished. Let's open the snapshot of this quickly. Yep, the main.nf.snap. So the snap always goes side by side with the test, and you have to commit this snap also along with the test into Git repos, so that this is version controlled as well. So yeah, so you can see here, this is how a snapshot looks like. All those different match names that they have given help you to organize all the different output and all the different files and the different MD files. Right, so this is just an example, and now you can rerun, because this is the first time we actually ran it. You don't rerun because I have one more command I want to show you that will kind of like rerun all. You can run all tests at once. So if you move to the next slide, yeah, boom, there we go. So the command to run all tests is nf-test. It's like seriously the most joy thing I found out is like, because when you end up with different modules tests, different sub-workflow tests, and different pipeline tests, you can use just say nf-test, and it's going to run the tests for all the test files it can find within the test repo. So this way, it's another way of running all the tests. Right, so this will run all the tests and make sure the snapshots match. I think that's all I had for today. Let's quickly go over the rest of the slides. Yeah, so the assertions order recommendations, again, as I said, we are still in the early phases of adoption in NF Core as well, and these are kind of like still evolving recommendations. So use assert all. Let's talk about that, because we use that in our test today. So if you go, could you quickly show one of the test files, the pipeline test file or the module test file? Yep. Right. So you see, assert all is basically you're wrapping all the different assertions into one assert all block. This is because if you don't do that, if any assertion fails, it's going to stop and it's not going to go on to the next ones, and it can be quite frustrating. So you wrap all the different assertions into this assert all block, and it's going to run even if some of the assertions fail, and give you at the end a list of all the failed assertions. So that's a great way of making sure that all the supplied closures do not throw exceptions. Use human readable informative names, test names in your test files, like provide what is the test file that is being used as input for the process. The test should contain at least process.success assertion. Let's go on to the next slide.
Should we take a few questions since we're running out of time?
Sure. Actually, yeah. So these you can actually look on your own as well. I'm pretty sure you have gotten a little bit of a head start on this, and you can find more information here and on the official docs. And also we have a channel on NF Core Slack workspace called NF-test. So if you're interested in more in discussing more, come join the channel and say hi and some more additional resources. And that's enough for me. Thank you so much. That was thank you for giving me the opportunity to present about this. Again, I want to see how the community get feedback about this particular tool and its adoption in the community. And I'll be happy to hear how the Wellcome Institute might find this useful. But thank you all for your attention. Thank you.
Thanks, Sateesh. Any questions for him, online or in person?
Just a quick question. I see you can look at the contents of a gzip file. Is it possible to do the same with a normal file? I presume it is just a .contains.
Exactly, and there is also the reader function. So all kinds of native Groovy functions can be asserted as well, can be used as well, different functions. So you can initiate a reader, read through each line, and also use .normal contains, find all Groovy methods work. So that's one of my excitements about this. Is there's a lot more of Groovy magic that we can do within these test files now, just for the same reason.
Yeah, that's really useful, because sometimes I often find the file content changes, so MD5 some won't work. I know that this line should always exist. Yeah.
Correct. I'll just give you an example of recently. It's in the slides, in one of the last slides I have it. We had to in the software versions.yaml, we had to remove, make sure, if you go one slide back, one more slide back. Yeah, down on this one. One more. Right. So we had to filter out the Nextflow version from the software versions.yaml so that we would get a consistent snapshot and not get a different snapshot each time there was a new release of Nextflow version. So we wrote a custom function where you can see it just reads through the YAML file, and then we remove that particular version key and assert only the map with the removed key into the snapshot. And in this way, you can work out different ways of getting consistent snapshots using these filtering methods.
Cool, thank you very much.
Sure.
I have a question.
Mm-hmm.
It's great how customizable it is, but again, how much development time was put into like creating these NF tests for like a single pipeline?
Honestly, pipelines are huge, right? Like, so they do take some effort. But my view was, I have written tests for all the different test profiles of AmpliSeq. So that's like 6 or 7 of them. So the most amount of time it takes is only for the first one, because you'll get the map of the output files then, and you kind of get an idea of which files can go into a snapshot and which files won't go into a snapshot. And from that bulk of the material, you're just duplicating the rest of the tests and making specific assertions. Either say if you're skipping FastQC or skipping QC, you just remove. So it's always best to start with the full default pipeline without skipping any parameters test, so that you'll get the full output. And then for the rest of the tests, you can use that and just chip off or add and edit blocks that might suit for that particular test. So honestly, it's yeah, the pipelines, because snapshots you have to keep running. It will take multiple attempts to get these snapshots right. But again, this is all totally dependent. It's all like, what is your ultimate end goal? Are you looking for specific things within your output assertions? Like, are you counting the number of mutations? So you can do that, right? Like, I haven't actually gone into it. You can write custom Groovy functions in library and provide them as well. You can test functions as well. So, but it gets quite exciting, because once you have it in, the rest of it, like, getting it into the CI and the snapshots all fall through easily. So I would say, yeah, it's only the initial hill. After that, it should, I found it quite exciting.